So we've made it to 1918. The Nobel laureate for that year in physics was Max Planck, someone who's probably as influential as Einstein on the physics being done in the lab today. Officially, his work was in recognition of the services he rendered to the advancement of physics by his discovery of energy quanta. Now, it's important to understand that Max von Planck did more than that. He was actually professor to Max von Laue, who won the Nobel Prize in 1914, 4 years before his professor did. But it's also important to note that Max von Planck, when he discovered the things that led him to the prize, it flew in the face of a lot of existing theories. It just contradicted much of what we thought we knew about physics. And he almost was kind of one of those guys who was like, I don't know if I really want to be the one on the hook for disproving all this stuff. So let's take a little bit of a look at it. And remember, this was more of a reluctant groundbreaker than anything else. But he was a groundbreaker nonetheless, because when you're working in the field of physics, you can't deny your experiment. If you know your experiment is correct and you know the theory doesn't fit, sometimes you've got to take your experimental results and look at the theorists and go, haha, you were wrong. The only trouble is Max von Planck was one of those theorists. So he was really looking at himself and saying, haha, I was wrong. And he probably did that forehead smack thing we all do when we are incorrect. But let's look at why. Now remember, Max's work dated back to the 1890s, the very latest part of the 1800s. And at this point in time, theories about light were being contradicted by many experiments all over the world. And those of you who work in the dark matter space might want to watch out, because some of your theories aren't necessarily being observed properly, and you might want to go back to the drawing board, just as Max Planck had to, no matter how hard it is. What he was doing was he was looking at a paper describing an experiment by Kirchhoff, who produced a heat effect from light. Now, he had a early thermal electric radiator apparatus in his lab, which was very rare at the time. Now it's fairly common. You'll see a modern one right there. But what that does is, in the barrel of that radiator, there's a lot of coils, and there's a way to heat the center up to a very exact, very uniform temperature. And what was going on was light was coming out of the little slit you see in the very end, the little hole, and you can detect that light with different scientific apparatus. Now, what happened was he was detecting things that got him backed into a corner. So what the observations were not fitting the current theories. Now remember, we've talked before, physicists always want to know why something works. We don't want to just say, there it is, okay, it's fine. We want to understand why, because when you understand why, you can make it work better, and you can make it work more to your advantage, and you can understand where else it applies. So he went back to work on a new theory so that he could find a way to describe mathematics that says, okay, now we can at least describe it mathematically. We sort of understand the why from this set of math, and now let's go off and look a little bit more closely. As the radiator heated up, light came forward out of that little slit, and the tube surrounded by the heating coil made it so that that light even came out in the ultraviolet. Now, at the time, the theories that existed said that to produce such a spectrum, an infinite amount of energy was necessary, which obviously wasn't going into his radiator, because Planck, being a normal person, understood there's not an infinite amount of electricity going into his lab. So he went, well, that's not good. He came up with this equation, and you forgive my sloppy handwriting, E equals hf. E is the energy of a photon, which he now just basically said that, hey, light has to come in these discrete packets of energy that we're going to call photons. And it's proportional to the frequency that comes out. The higher the energy, the higher that frequency. And it's multiplied by this constant, which was later worked out to be 6.626 to the times 10 to the minus 34 joules over hertz. He called it H. Depending on which story you believe, H was just a choice he made, or according to one of my favorite science historian, James Burke, it may have stood for help. I don't know what this is. Now, that paper was published in 1899. It was not widely accepted by anyone in the scientific community at that point. People didn't necessarily say it was wrong, but it wasn't widely, okay, this is exactly what it is, because they're not used to these little discrete energy packets. Those are not normal. Those are now called quanta. It wasn't until 1905 when Einstein corroborated his findings with one of his groundbreaking papers and said, yes, those really are discrete packets of energy, or quanta, and the word quantum mechanics and the field was born right there. Now, I hear you, quantum mechanics, that's just a bunch of stuff scientists off in a lab talk about, right? Well, sure, but not exactly. Without quantum mechanics, we wouldn't have things that we enjoy every day. Certainly the fiber optic carrying my internet signal from YouTube over to you to watch the video wouldn't exist. We wouldn't have lasers, we wouldn't have transistors, we wouldn't have light-emitting diodes that enable everything from the flat-screen TV that you now have that replaced the 200-pound CRT that your parents had to the flat-screen huge displays at sports arenas. So really, if you think about it for a second, you got to go back to 1899 and thank Max Planck for saying, hey, maybe some theories are wrong and we should correct it the next time you go see a sporting event and you enjoy that gigantic screen in the middle of the arena. That, I think, is an idea that has stood the test of time and really, really changed lives of many, many people. Quantum mechanics is not just a funny thing for people in labs, it actually does change lives. I hope everybody's enjoyed this video. Please don't forget to hit like and subscribe. We got to make the channel grow, and thank you for doing that. That is the one way we have of supporting these videos in the future. Everybody have a great day.